Jen, would you start us off? Introduce yourself and your idea in 3 sentences.
Hi, my name's Jin Lee. I'm an assistant professor at Stanford University in the departments of neurology and bioengineering. My research is around understanding the neural circuit dynamics. And as we just heard, there's a lot of these nervous system controlling our body. And my research approach is trying to understand how in detail the dynamics work. There are connections in place, but we really know very little about how they connect and how they function under these connections. And so by uncovering some of these, we're trying to come up with innovative approaches to make us live longer, hopefully.
Hi, my name is Scott Wolf. I'm a physician by training, but I've spent my career starting up medical device companies. So I'm a serial entrepreneur. And my research is in the effect of an organ that we don't think about as even an organ, which is adipose tissue. And what effect the compounds produced by adipose tissue has on inflammation in the body and the metabolic state of the body. So it produces compounds that are quite negative, cause inflammation, and some that are quite positive that Dr. Imai will talk about.
I am Brian Olshansky. I'm a professor emeritus at the University of Iowa. I'm a cardiologist in practice, and I've been involved with autonomic research for the past 30 years. We have a very strong team in basic and clinical research involved in understanding and deciphering the aspects about the vagus nerve, both the afferent impulses into the brain and out of the brain that can both help improve ability to maintain homeostasis and reduce the risk of mortality. We already have some clues as to where aging comes from in relationship to the autonomic nervous system, in particular with respect to the vagus nerve. But where we want to take it to the next step in an animal model to show that by enhancing vagal activation, we can improve survival, and not only survival, but healthy survival.
Hello, my name is Shin Imai, and I'm a professor in the Department of Developmental Biology at Washington University School of Medicine in St. Louis. I have been in the field of aging longevity research for more than 27 years, and so I am really interested in aging longevity. I'm excited with this event. And last year, our team has demonstrated that by manipulating a key aging regulator in the brain, we can actually significantly delay aging and also extend the lifespan in mice. And turns out the key area of the brain is a very tiny area we all have, which is called the hypothalamus. And actually, we identify a very specific subset of neurons which control aging and longevity. And these neurons also regulate sympathetic nervous tone. So basically what we found is it has a direct relationship with one of the theme in this competition. So we are pretty excited to take our research to a next step. And right now our team is basically in my lab, and I'm still looking for a teammate and also somebody who is interested in our research, to win this competition. Thank you.
Hi, my name is William Cyril. I am the founder of the New Genesis Institute and a biochemist, entrepreneur, and leader of Team DECO. DECO stands for Decreasing Consumption of Oxygen. It's a hormone that was discovered about 40 years ago, but never fully identified by Donner Denkler, an endocrinologist. It's the death hormone. It causes aging. Following a suggestion by my son, who's a graduate student at McGill in the Division of Experimental Medicine, we realized that DECO could function as a hormetin. That means that if large doses of it promote aging, small doses would be a youth hormone. And in support of this, we already know that small doses of a candidate for DECO that we've identified, in fact, increase heart rate variability and are neuroprotective, whereas large doses are deleterious to the animal. So we're looking forward to expanding this research and possibly to nailing down the nature of DECO after all these years, because it was never fully identified. And we think we have a good handle on it. The other members of my team include Dr. Albert Dahlberg from Brown University and Dr. Timothy Marr from the Massachusetts College of Pharmacy and Health Science. He's chairman of the Department of Pharmaceutical Sciences. Thank you.
Great. So one of the hopes of prizes like this is to encourage collaboration. As we know, when the stakes are small, people tend to divide. When the stakes are high, people tend to unite. And we feel like the Scientific Advisory Board set a pretty high bar for winning the prize, although everybody on the stage believes they can win it. And the reason to set the bar high, of course, is that if there are things that each of these teams need to achieve that high hurdle, they're in position to ask. So what I would like to ask each of the team leaders is to say what you think is great about one of the other competitors' ideas, and you can't all pick the same person. Dr. Shinemai.
Yeah, because to answer that question, it's kind of easier for me because I'm interested in sympathetic nervous system, autonomic nervous system, and basically the mice we created show really a significant benefits related to this topic. And of course, Dr. Lee and she is an expert for neuroimaging, and I really want to look into what's going on in the brain initially in mice, unfortunately, but then eventually in humans. So I can clearly see it as a very interesting scientific interaction, I could possibly, develop. And also with the, Wolf, and I can also, of course, we kind of share similar interests as we discussed, because, believe it or not, to support the hypothalamic function, adipose tissue, our adipose tissue, is actually important. So there is something interesting going on between the brain and adipose tissue. And also these two other contestants, I can also see them in some potential. So maybe, I shouldn't compete against these people, and I should maybe collaborate with them.
If I could say, I also agree that everyone here has fantastic ideas. I do think, though, one issue that comes up, and one of the, I think, strengths of our program, and one of our members of our program here is Steve Michelson in the back, and that is that it's a multidisciplinary collaborative approach, because each one of us comes to the table with a different thing. I don't know that it's a single bullet theory kind of thing, because we hear, for example, it might be the hypothalamus, it might be the fat, it might be this, it might be that. Even today in the news, you'll see that a recent manuscript of many thousands of athletes show that simply exercising 1 hour a week is as good as doing marathons all the time to extend life an extra 3 years compared to people that don't. So there's something about ramping up the system, and it can come in many different ways. But we're not just trying to ramp up the system, we're going to go turbo ramp the system. We're going to go one step further than that. But we begin to understand that each one of the issues, whether it be a compound that causes death, whether it be fat, whether it be the hypothalamus, all of these contribute. But I think with time and effort and collaboration, we can work together to get to the source of what the real issue is all about.
So just to show you how independent and innovative the teams are, June, I'm not going to answer your question. I'm just going to say there already is collaboration, just even from today. Dr. Imai, unbeknownst to either of us, are both working in visceral fat. So, and I see a lot of collaboration possibilities already, just from today.
Well, I agree with everybody that actually it's really exciting to see a group of people who take interest in this problem from different angles. And one of the things that to answer June's question, one of the things that I can provide as a collaborator to all of you is that in understanding and trying to tune a certain system to behave a certain way, you have to know, you have to be able to see what the system does. And without having that feedback, it's very difficult to fine-tune the system. And one of the things that we are focusing our attention on is to be able to visualize it very well. And by having that mechanism combined with all of your expertise, I think could be the key to trying to tune the system well. And so I'm very excited to learn about all these.
I'd like to add my piece to that, and thank you all for sharing what you have. I find myself in agreement with everybody. I think there's tremendous potential for collaboration here, that we each have a piece of the story, and that there are overlapping pieces. I particularly resonate with Dr. Amani's work because there's a hypothalamic connection with my work as well. And there are pathways, for example, the target molecule that I've identified as DECO also has effects on the mTOR pathway and also on stem cells. It would be fascinating to see all the different components that we regard as involved in aging or longevity, how they can all interact in a variety of models and perhaps find commonality. And there's tremendous potential, not just for convergence and cooperation, but for unlocking the code, which is what we're all looking for.
Great. I promised the audience I'd only ask 2 questions. The second question is a 3-part question. But each of the questions can be answered in a single word. So the 3 questions to our team leaders are, how long do you think people can actually live? These are the burning questions in our minds. When do you think we'll get there? And what is your favorite recommendation and how we can improve our longevity today while waiting for all of you guys to be successful?
How do you answer that with one word? Okay, how long do you think we could live?
Personal opinions only.
Personal opinion, I think 120 is a good number. There's been some proof that shows that we can live up to that point. I think a lot of the things that we're talking about and trying to balance and retune the system has a lot to do with trying to maximize our potential lifespan. But beyond a number like 120, if you want to go up to something like 200, that would require dramatic changes like changing your hardware. And so I would think that's a number I'm comfortable with, 120. And how long it would take to get there. I think a lot of different technologies are maturing and people are gaining insight, and something like this is providing opportunity for us to gather all the ideas together. And something like 5 to 10 years is not too dramatic, I think, where it depends on how efficient we can be in gathering these ideas and executing. And as you all know, like collaborations and making teams work together is not necessarily that easy, but with more resources to make that happen, I think we can accelerate that. And as June mentioned, we're all dying, we're all on our path. We might as well accelerate for all of our sake. This is the sentence that was most touching when you said it was that that we all win. This is a competition context, but we're all in the same boat in terms of aging, and so I think we should really try hard to put all our resources together to win. What was the third one?
What advice do you have for the audience today?
Well, let's all work together. That's the advice. I think everybody can contribute and have interest in this, whether it be like trying to put people together and get people excited or put money into it. All of it, I think, there are many different ways that people can contribute, and let's just all work together to make it happen.
This one. So there's examples of immortal human cells. Cancer cells are immortal, so I'm gonna take a leap and say 300 years. And how long will it take to get there? A long time. But there's no limit to this question, so I'll say 100 years. And second part of the question.
The third was advice for people in the audience. What can they do today that's going to help?
What can you do
improve
today?
longevity?
The only thing that seems to increase actual longevity or ultimate lifespan is calorie restriction. So I would recommend that everyone eat about 400 calories a day for the rest of their lives.
think 150 is totally realistic. I think we can go beyond that. I think to get to 150, it would take probably 5 to 10 years. And if I were to make any comments, and this might be a little bit of a longer response to the final thing about what we can do today, we already know some things. And unfortunately, for the younger generation, we're going in the reverse direction. That's pretty clear. We're going to have a biphasic mortality curve. The older people are going to live longer, younger people are going to start dying of diabetes, hypertension, obesity, and all kinds of other things. And this happened in one generation. And so there's some very simple things we can do. And I want to say, I'm emphasizing it's important to do that, because right now I'm a cardiologist, I'm 62 years old. And I see patients 20 years younger than me who look 20 years older than me. And there's a good reason. It didn't just happen by accident, because all the men in my family were dead by the time they were 62 years old. So it didn't happen by accident. But we know some things that are not good. We know the diet that we're eating is no good. We know the activity is no good. We know that we can enhance vagal tone, and that will improve survival. So proper activity, increasing vagal activation, staying away from major stresses, but knowing that stresses are part of life, and we can't just avoid them. We can't just sit there and meditate all the time. I mean, you can do it a little bit, but really we have to live our lives. And I think it's important because it took me 62 years to get to the top of my game. And it's kind of ironic and unfortunate. You get to the top of your game and it's time to retire. That's not the way it should be. Right now, I should be able to live another 60 years and be able to accomplish what I can, knowing the tools that I have right now.
All right, so I would give you a little bit more realistic kind of a thought, because I have been working on aging and longevity. So based on our research, currently we could extend the lifespan of mice about 20% or 30%. So if I just simply apply those numbers to humans, that means we could achieve 100 years old, or maybe up to 120 years old, which basically Dr. Weinstein mentioned. So maybe 120 is some kind of magical number in terms of longevity. But here is an interesting thing. So based on our results, the mice we created, females. Good news for women here. Females, extend about 20% lifespan, which means that, if I apply this number to women, that means that women can live extra 13 or 14 years, which makes the average about 100 years old. I think, that number is still very significant. For gentlemen here, unfortunately, we saw about 9% lifespan extension, which means several extra years, which is probably good enough. So I would say 100 years old is definitely, promising based on rodent research. And if, we can apply everything we could do based on the results from this longevity prize, maybe 120 years old, which is basically 50% lifespan extension, roughly. And when could we achieve those results? I would say 5 or 10 years. If everything works out as we expect, based on our research, 5 years is not an exaggeration, because we are working on, people in this field are working on this issue, and now we have some genetic methods or pharmaceutical methods to do it, at least in rodents, not in humans yet. So, I would say 5 to 10 years. And then my suggestion is, there are two important things. Eat moderate. I wouldn't say 400 calories, but eat moderate is very important, and also exercise. So nothing special, but these two are very important. But then I want to add one more thing. So this is something that young people here can forget about. But once you get to, let's say, 50 years old, 60 years old, forget about diet, because our adipose tissue is definitely important to support the brain function. So if you don't have appropriate amount of adipose tissue, your brain function might be really affected. So even when I try to exercise, I'm not doing a diet. Instead, following your circadian cycle, that's very important. So for example, what I'm trying to do these days is that I'm eating almost like a dinner-like breakfast, at the very beginning of your active time, and then eat decent, lunch, and then eat very light, and then don't eat much, during the nighttime. That actually, in rodents, this type of, like a diet cycle is actually very important to maintain the healthy metabolic parameters. So, I can see a slight reduction in body weight, but then interestingly, the major effect is on sleep quality. So that's something very interesting, and if you want to know more details, I'll be happy to explain. But, those are something you could try immediately, so that's all.
Well, the first question about effective lifespan, I would say that first of all, I agree in general with everything everyone has said. We all seem to be zeroing in on the same numbers. What I would say today, there's a generation of baby boomers who are approaching 70, and the word is that 70 is the new 50. Well, I think 150 is the new 100. And I believe 150, it may be even conservative, it's a reasonable estimate. With Donna Denkler's experiment on rats, when he removed their pituitaries and supplemented them with thyroid and adrenal hormones, he found that 20% of his population lived to about 34 months of age, which for a rat is about 150 years. So I believe something even better can be done if we find the appropriate tool that would mimic the beneficial effects of the death hormone at low doses. So that's one factor. How long it takes to get there? I'm in agreement that 5 to 10 years is entirely possible. I think it's doable. The last question, recommendations for longevity, certainly exercise. Moderate alcohol drinking, not necessarily red wine, any kind of moderate alcohol drinking. There's no magic in resveratrol yet. Lots of sex, it actually helps with longevity. Thank you. And a recommendation to take DHA, fish oils, docosahexaenoic acid, in amounts ranging from about 2,400 to 3,600 milligrams a day. It lengthens telomeres. And so a combination of dietary factors, lifestyle factors, meditation as much as you can stand it or sit it, whatever works, this combination is going to make a difference, at least until we can get the new anti-aging strategies out there. Thank you.
All right, thank you all. Well, that was great. It was great to hear from all these amazing competitors. And while we get the chairs off, I guess we could leave them on here. I should probably give my answer too, because I think the teams, my guess is they're all lowballing. Scientists are notorious for under-promising and over-delivering. That's the grant mechanism. So when I hear that we might be able to live into the hundreds, there certainly seems like doable. I'm going to answer the question myself too. So since I don't have a horse in this race, I'm going to say we can live 10,000 years, and that's based on the following. If we can restore homeostatic capacity to that of a 12-year-old, the per annual mortality rate of a 12-year-old is 0.0001. So if you can live at that mortality rate, that translates to 10,000 years. And even then, the causes of death at 12 are things like car accidents, poisoning, infection, things like that, right? So that's a statistical average. If you can live at the per annual mortality rate of a 25-year-old, their mortality rate is 0.0001. 0.001. So you would live, statistically, you'd live 1,000 years. So restoring homeostatic capacity would completely change the way we think about lifespan. In terms of how long it will take to get there, soon. In terms of advice for longevity today, I was going to say exercise, because exercise gives you a 3-for-1. You get exercise. If you play team sport, you also get friendship, and you also get better sleep. Although if you do William Sorrell's, if you drink, you also have more sex. You get 2 for 1 there too. Without further ado,